Okay, we have an example, and we are going to observe the convergence of this series. Its general term, logarithm k over square root k plus 1. This is the general term. So in order to apply the limit test, if we take alpha equals 1 over 2, and we are going to find an L. So let's look into this limit, and from the properties of the limit we can calculate separately these limits. This one is equals to 1, and this one we know already it is infinity. Here is 1, and this limit is equal to infinity. So our alpha is equal to 1 over 2, and L greater than 0. Then our limit test, as we learned, says our series is divergent. I mean this second item. Yes. And we choose alpha smaller than or equal 1, and we found L is greater than 0. So the test says our series is divergent. So we have another kind of test, theorem 4, and the Alembert ratio test. We call it shortly ratio test. Yes. This is both simple and very useful. So let's write. Let a k be a positive series, and the limit of the ratio of ak plus 1 over ak, let's say L, if L smaller than 1, then our series convergent. If L greater than 1, our series divergent. Last item, if L equals to 1, then the test doesn't work. Namely, says nothing. So in this case, we will give another kind of test, and at the moment omit the third item. Example. Okay. Observe the convergence of this series. Okay. We may use the ratio test. For such a series, AK equals to 3K over, and we say it factor, and a k plus 1 equals to over k plus 1 factorial. Then ak plus 1 over ak equals to k plus 1 factorial 3 times k factorial, and we may write by using the properties of k factorial. We have, and by the way, I have a mistake. Just a moment. Okay, we may write here yes, this is the correct version, and we write yes. And if we take limit ak plus 1 over ak, we will obtain zero. So, and we have obtained an L. L is 0, smaller than 1. Then test works and says as convergent. And I think with our theorem is 5, theorem 5, and it's called and we call it shortly root test. Okay. As usual, let AK be a positive infinitive series. And say L if L this is similar to that of ratio test. If L smaller than 1, then our series is convergent. If greater than 1, is divergent. And analogously, if L equals to 1, then the test doesn't work. For such situations, as I said before, we have another test. So, an example. Okay. Determine the convergence of for the solution. and we may use root test, and here the general term and the root, square root, of course degree of k, okay. Let's take limit. Here is a very known limit. I mean this one equals to the irrational number e, then our L equals to 2 times e, greater than 1. Then our test says our series is convergent. Another example. Okay. Consider this infinite series, and let's observe if it is convergence. Or not. Observe its convergence. For the solution, we may use root tests. Okay, the root of degree k, ak, equals to 5 over k, then limit is simple, 0. Our L, here is L, smaller than 1, then our root test works and says us convergence. A note: in case the ratio and root tests do not work, we may use rabbit test. Okay, this is the last series. This is the last theorem or test for the positive series theorem. We use this test only for L1. Okay, as usual, be a positive series. And say this limit capital K if K smaller than -1, then our series is convergent. otherwise divergent. An example: of course, always we may consider firstly ratio tests for such examples. I mean, such a series examine the convergence Okay, we should consider firstly the ratio test, and then if it doesn't work, and we should take the Rabat test, because the ratio test is simpler than Rabat test. Solution: okay, AK plus 1 over AK equals to, by the way, let me take here. Okay, 1, 3, 5, and the odd numbers and even numbers, and of course, if we take AK plus 1, then we have to write here 2K plus 1 and 2K plus 2. Okay, for AK we must write here 2K over 2K minus 1. Okay, some terms disappear and we have only this one. Of course, if we take limit, one, and in this case the ratio test does not work, so we may use the Rabat test. I mean, we need AK plus over AK minus 1, so it's clearly minus 1 over K plus 2. So then we have limit K AK plus 1 over AK minus 1 is equals to limit, and this is equals to minus 1 over 2. So, and our capital K, as in Rabat test, as you see, minus 1 over 2 and is greater than minus 1, then Rabat test says our series diverges. A note: Rabat tests shouldn't be used directly. First, you should use ratio or root tests. Okay. Okay, as we emphasized, and we have considered three classes of series. This one, the first one, positive ones, and then alternate or alternating series, and the last one is power series. So now we are going to present alternating series. Okay. Alternating series. Okay. A series of the form is called alternating series. Here, AK positive numbers. Okay, let's write it simplicity. AK and A1 minus A2 plus A3 and so on. Namely, it's a series whose terms alternatively or successively positive or negative. And we have only one test called Leibniz tests, which is simple, and let's provide it. Be an alternating test if the positive AK sequence holds the following both conditions. I mean, AK is decreasing, namely AK greater than or equals AK plus 1, and the second condition, limit AK equals to 0, then our series is convergent.